We usually picture the cosmic microwave background as a static baby picture of the early universe, a frozen afterglow from the Big Bang, locked in time. That image is entirely incomplete. It is a superficial layer masking a highly active, ongoing physical system. To understand how this system works, we turn to the research of theorist Clinton Alden and the Kosmos Institute of Systems Theory. Applying their framework reveals that the universe at this stage is a deeply complex 28-node structural machine, running continuously with active inputs, processing channels, and feedback loops. Shifting our perspective from a single historical event to an active structural machine completely changes how we map the mechanics of the early cosmos. Every machine requires inputs to function. The cosmic microwave background does not just sit there holding ambient heat. It actively ingests multiple distinct streams of cosmological data. The most obvious energetic input is the immense thermal energy of the primordial plasma left over from the Big Bang. But there is another mechanism at work called the Sachs-Wolf effect. This is an input driven entirely by gravity, where space-time itself forms deep topological wells. As photons climb out of these gravitational valleys, they are stripped of their energy. Photons traveling across flatter, underdense regions gain energy. This specific exchange of energy creates a precise informational layer. It permanently encodes the structural geometry of the early universe directly into the radiation field. By recording these gravitational variations, the background radiation acts as a universal hard drive, pulling the physical architecture of the cosmos into a readable format. With all of this energetic and gravitational data ingested, the universe has to actually process it. The primary pathway for this computation happens through acoustic oscillations. These are literal sound waves rippling through a thick fluid of photons and matter. These primordial sound waves translate physical gas compression directly into measurable temperature fluctuations. Where the gas compresses, it heats up, and where it expands, it cools down. As photons diffuse through this plasma, they trigger a mechanism known as silk damping. This process actively erases the smallest microscopic variations in the field. Under the systems framework, this erasure operates as a mode deficiency cascade. The system purposefully filters and irreversibly loses data at the smallest scales. Much like compressing a raw audio file into a lossy MP3 format, the universe's processing mechanisms filter out microscopic noise to stabilize the larger macrostructure. All of this complex processing eventually hits a physical wall, a boundary known as the surface of last scattering. This is the ultimate boundary where the early chaotic plasma cooled enough to let light travel freely. This boundary acts as a universal translator. It takes all the three-dimensional plasma data we just discussed and projects it perfectly onto a flat, two-dimensional map across our sky. This projection simultaneously broadcasts multiple independent channels of information. We see the basic temperature variations on one layer and the directional vector lines of E-mode polarization on another. Running parallel to that is a third channel, B-mode polarization. This swirling, distinct pattern is generated entirely by the stretching of space from gravitational waves. This universal boundary broadcasts a layered, multi-channel transmission of the cosmos's most extreme physics. Looking at these overlapping layers of inputs, processing pathways, and outputs, the sheer complexity defies the idea of a simple historical relic. This diagram illustrates the system's internal variety, the sheer number of possible states it can hold. For the background radiation, that number is estimated as 10 to the power of 69,000. Ashby's law states that a system remains viable only when its internal complexity matches the complexity of its environment. With this many internal states, the CMB possesses the variety needed to absorb and counter almost any environmental disruption. This immense structural resilience allows for passive temporal feedback. It explains why the radiation has survived for 13.8 billion years. The system persists because its architecture is robust enough to endure the expansion of space itself. When we observe this light, we aren't looking at a dead museum artifact. We are viewing the foundational blueprint, the source code that defined the distribution of matter and the very geometry of the universe we live in today.